for the promotion and application of the green, low carbon, and zero carbon technology approaches and solutions. This session will explore the various emerging technologies, innovations, and developments, and how issues and challenges can be addressed in order to encourage and support the development of the green, low carbon, and zero carbon technologies. This session is organized by our good partner, the Administrative Center for China's Agenda 21. Much appreciate your support and contribution on this important session. First of all, let me invite Mr. Sun Hong, Chief Engineer of the Administrative Center for China's Agenda 21, to address opening remarks. Before his speech,
好，尊敬的徐金苗先生，尊敬的各位同行，各位来宾。
Ladies and gentlemen, good afternoon. First of all, on behalf of the CAAC 21, I'd like to extend a warm welcome to all of you. And this parallel session is themed as the road to carbon neutrality, emerging green, low carbon, and zero carbon technologies, which is highly relevant. Climate change has led to more frequent and more serious climate change and has posed great challenges to the grain production. China has always attached a great importance to tackling climate change. On September the 21st this year, at the general debate of the UN General Assembly, President Xi advocated that China will reach a carbon peak by 2030 and carbon neutrality by 2060 by accelerating a transition to low carbon development and green recovery. This has added great impetus as well as faith to the global tackling of low carbon development. Scientific and innovation and technology is an important goal for carbon neutrality. And this requires restructuring of the energy sector and the green development. And to that end, we need to accelerate the industrial restructuring and improve the energy mix. Carbon neutrality requires a shift to clean energy and low carbon energies. This will bring about a new round of technology revolution. All this has called for low carbon or zero carbon technologies, products, equipments, and we need to accelerate the supporting services to accelerate the R&D of relevant technologies. Driven by the green development, the human world will embrace a new round of revolution in economy and society. And gradually, we will develop a low-carbon development philosophy by balancing economic development and improved people's well-being. Climate change is a common challenge to mankind. The developing countries need to work together to coordinate economic development and climate change. Together, we need to drive technology innovation and play a pivotal role to Belt and Road Initiative.
And we have mapped the specialized planning to promote technological transfer as one of the 4 major strategies by promoting South-South cooperation and to address the climate change jointly. Ministry of Science and Technology has worked with ADB and UNDP to promote the cooperation between developing countries in terms of renewable energy development. In 2019, we signed a cooperation agreement with UNDP to establish a South-South Cooperation Center for technological transfer. We worked with Ghana, Sri Lanka, and worked on some technological transfer projects. And we have improved their mitigation and adaptation capacities. These cooperation projects has been included in the UN South-South Cooperation Program to promote the sustainable practices. To better address climate change and attain the goal of carbon peaking and carbon attainment, we have the following three focuses. First is science and technology-driven plan to coordinate technological innovation for carbon peaking and carbon neutrality. Second, to formulate a China roadmap to carbon peaking and carbon neutrality. Third, we set up a carbon neutrality key technology R&D and demonstration site. We have achieved initial success in the three aspects. It's our great pleasure to attend this forum and discuss the efforts with all the distinguished speakers and panelists. We hope we can have better cooperation in the concepts and practice as well to promote multidisciplinary and cross-region cooperation and promote low-carbon and zero-carbon technologies and to build a beautiful, clean world. To conclude, I wish you complete success. Thank you for your full support, and I would like also to thank the organizers for all the hard work. Thank you all.
In order to save time to our speakers, I will change to Mandarin to host the rest of the session. 为了省时间，我下面还是用中文。
In the interest of time, I will now shift to Mandarin because many of our guests are Chinese speakers. Thank you, Ms. Sun, for your introductory remarks. He briefed us on some of the work China has been doing, and now let's enter the keynote speeches. Our first keynote speaker is Professor Guan Dapo from Tsinghua University. He has been an elite for carbon peaking and carbon neutral targets. And he's also with the UK National Academics. And he has been a specialist on the causes and the results of carbon emission accounting. And he has been awarded many times for his scientific research. And now let's give the floor to Professor Guan on the title of Carbon Accounting System for Emerging Countries. Thank you, Mr. Host, and thank the organizer for your invitation. Let me share my screen with you. Dear colleagues, ladies and gentlemen, good afternoon. My topic today is the carbon emission accounts and database for emerging economies. We are a working group on the carbon emission accounts, and I am part of the project. I'm with Tsinghua University. Guan Dapo. Today, we are going to release this carbon emission accounts based on the support of Science and Technology Ministry of China and the CAAC 21. First, please allow me to introduce to you the status quo of the accounting system. We had done a lot of work on the database. Apart from the database for emerging economies, we have data sets for other countries as well, which I would also like to report to you later. And so the database focuses on the accurate accounting. It's multidisciplinary accounting system. It has played a great role, great contribution to the Belt and Road initiatives. For the carbon emission accounting system, it covers 20 energy products, covering 47 departments and 20 industrial products at both the national and the provincial level. For the background, while the world temperature is rising, over the past, CO2 emission across the globe has been increasing rapidly. That's why we have been doing this accounting system, and we are calculating it under the high climate risk scenario. If we want to contain the temperature rise within 2 Celsius or below 1.5 Celsius, we still have a long way to go. Both developing and developed countries need to contribute a lot. So on this scenario, we found that some emerging countries, their accounting for emerging economies are still inaccurate because many countries are still missing on the list. That is why we decided to focus on the accounting system for emerging economies. Also, how much quota of the CO2 emission is left? If we target for a 2-degree Celsius rise in temperature, globally, we need to emit altogether 3,700 gigatons. Given the current number, there is only 800 gigatons emissions left. So it's impossible for us to store any quota from anywhere. And altogether, globally, only 800 gigatons emissions quota left. So here comes another question, that is the allocation of the quota. Who gets the quota? For the 4 major economies in the world, the EU, US, China, and India, over the past decade, India has emitted rapidly. China, of course, was also a large emitter, yet its emissions gradually flattened off. Major economies like the US and EU have pledged for carbon neutrality in another 10 or 20 years. But the important question is whether the quota is still enough for other economies, for example, India. So under such circumstances, such a background, we need to have an accurate calculation on the carbon emissions for developing countries. I would like to explain the connotations of carbon peaking and carbon neutrality for developing countries. Carbon peaking is a matter of decoupling of socio-economic development and the use of fossil fuels, because in the past, economic development has been achieved together with carbon emissions. During the period, the per capita GDP would rise steadily. And for developing countries, carbon peaking means a decoupling, whereas a carbon neutrality means an end to the reliance on fossil fuels. But what does it mean for developed countries? Developed countries, for example, the US actually peaked back in 2005, and it pledges to peaking in around 5 years. This means that in the next 4 to 7 decades, the country would shift from peaking to neutrality, while the time given for China is only 30 years. Also, the current CO2 emission is projected to be even larger than US or the EU, almost double their level. That means we need to cut our carbon emissions within shorter time, but cut more. So you could see the challenge. In the future, emerging economies would have even a more arduous task in achieving carbon neutrality and carbon peaking. That's why they'll need our help. So taking this opportunity today, I hereby to release the SC's Annual Report 2021 for carbon dioxide emission accounting for emerging economies. This is the first release, including 30 emerging countries, 25 of which are actually regional emissions. You can see the map here. And this is the version 1 of the carbon emission. And you can see all the emerging countries listed here, including Myanmar, Cambodia, Laos, India, together with its 33 federal states, Mongolia, Russia, with 28 federal states, and Bolivia, and some Southern American countries. So our accounting methods is unified with the coherent format and formula. And the calculation is based on the raw material, raw data, according to the data released by the local authorities. And we have compiled this accounting system for different countries based on the raw data. After collaboration and verification, we came to the final accounts. In the interest of time, let me cite one example, two examples actually, Myanmar, to begin with. Its energy mix is heavily reliant on fossil fuels like petrol and natural gas. Because the country doesn't produce petrol itself, it contributes to 6.3% of annual growth rate of fossil fuel CO2 emissions, while its biomass was basically used for households. If we apply the formula to the data in Myanmar, we could see from 2010 to 2018, its carbon emission has increased by 30 to 50%, mainly because of its consumption of fossil fuels, building industry, power generation, and the energy gasoline industries. If we look at Ethiopia, it would be another story because its primary energy comes from non-renewable resources. and its fossil fuel also increased by 3.4% in terms of its emissions. And its biomass used in residential sector is not very popular. That is, its biomass consumption is not sustainable. Sorry, we are losing the signal here. It seems that Professor Guan is offline. I'm afraid we have to wait for a moment. In the
interest time, let's move on to next speaker. So we talk about carbon peaking and carbon neutrality, and I believe all the countries also have other ambitious targets. Actually, climate change is a common mission of all mankind, and that makes the international cooperation necessary. Now let's move on to Sujata Gupta, Director of Sustainable Infrastructure Division of ADB. And he will talk about international cooperation under the framework of carbon neutrality goals.
World is facing today, and there are lessons to be learned from here. So we have really a tale of two global crises. One is the global COVID-19 pandemic, and the other is the climate change crisis. The global COVID pandemic was a real shock to the entire world. It killed millions of people and it impacted billions. Similarly, the climate change crisis, it's changing the world. It's impacting not only human beings, but almost all species. A small difference, in some areas, this is a gradual impact, which may be more dangerous because it's irreversible. And we are already seeing some sudden impacts which are causing a lot of death and destruction via extreme and catastrophic climate events and other events like forest fires, floods, etc. So it's very important to deal with this impending and actually something which we are already in the midst of, climate change crisis, and draw lessons from how the world has faced the COVID-19 pandemic. If we look at the climate crisis, in the last less than 200 years, we find that global temperatures have risen very steeply. And in the last few decades, these temperature increases have been spectacular. The impact of these high temperatures is manifested in hydrological events such as floods, mass movements, in climate events like extreme temperature, droughts, and forest fire. So if we see the graph on the right, we find that in less than 40 years, the climate events like extreme temperature and drought have almost doubled, and hydrological events like floods and mass movements have increased more than 4 times. So this just shows the enormity of the problem. Now, how do we fight a crisis? In my view, we need to do 2 things. One, we have to be clever, we have to be creative, and we have to innovate to deal with the challenges that a crisis puts in front of us. But also, the second thing that we need to do is to coordinate and collaborate. Without coordination and collaboration, we cannot solve a global crisis. And I like this picture on the right, which shows the collaboration and coordination amongst these young men to save a life. So when innovation was applied to vaccine development against COVID, this was, I would say, an extreme innovation. In less than 1 year, the vaccine was developed and put into the arms of people. And the impact of this is evident from these 2 graphs. We see on the left-hand side graph, the dark blue line is for people aged over 85 years, and the pink line is for younger people, 18 to 49. And we find that without the vaccination, the rate of hospitalization for those aged 85 and above was much higher than for those in the younger age group. But after vaccination, when say 10% of the elderly were vaccinated, we see in the graph on the right that the rate of hospitalization declined faster for the old people compared to the younger generation. So the vaccine actually saved millions of lives. And for climate change also, we need to have similar innovation and global collaboration. If we look at the climate change technologies or climate safe technologies, and if we measure this looking at the patent activity worldwide in environmental technologies, we find that human ingenuity and technological progress can help us to slow down climate change. So we see wind power, solar photovoltaics, patents increasing, and it's evident also in the real world with costs coming down for these technologies, and these being really technologies that are helping us mitigate climate change. So it is very, very important that we continue to invest in these new technologies and business models to fight the climate change crisis. All this technology and knowledge gets multiplied manifold if there is cooperation and collaboration and sharing of this information and a transfer of technology. This graph illustrates the international collaboration in wind power technologies in its initial years. And as you can see that there was a lot of collaboration between the developed countries, but also between the developed and developing countries. So this is very essential. So you can have innovation and technological advancement, but cooperation and collaboration or global collaboration increases the effectiveness and efficiency of these solutions, especially when we are looking at a global crisis. Now, if one looks at the evolution of international cooperation, less than half a century ago, maybe when ADB had just been formed, cooperation or transfer of knowledge and technology was from the developed countries to developing countries, or what was called North-South cooperation. But subsequently, there was also collaboration and cooperation between developing countries. And there was the South-South cooperation. Developing countries were able to learn from each other. And a newer stage is where even developing countries are contributing to evolution and international cooperation to developed countries. So now there is a triangular innovation that's taking place between developing countries, developed and developing countries, and developing and developed countries. And in this, the multilateral development banks, like the Asian Development Bank, have a role to play. They need to facilitate this process and can do this and are doing it. So let me show what the multilateral development banks have done to support the climate change efforts. So this graph shows the climate finance commitments over the last 5-6 years by World Bank, Islamic Development Bank, Inter-American Development Bank, EIB, BRD, AIIB, ADB, and the African Development Bank. And we find that climate finance has been increasing and reached almost 43 billion in 1 year in 2018. Subsequently, it has declined, and it went down to 38 billion in 2020, and this was because the MDB resources were diverted towards fighting the challenges of COVID. And if we see where these climate finance resources from the MDBs have gone, we find that developing Asia is responsible for consuming 42% of the MDB financing. So going forward, development partners and MDBs play a major role to facilitate international cooperation. And they do have the knowledge and resources. They have knowledge from each, a wide spectrum of countries, which can be shared with other countries. And they have the resources to support this knowledge transfer, financing of innovative technologies, adapting and building resilience to climate change, transfer of knowledge and technology, and most importantly, strengthening the institutional capacity of those organizations that are responsible for mitigating climate change and adapting to climate change. And we have to bear in mind that climate change is a threat to the world that is all pervasive, and we need to go all out to combat this, and we need a multi-dimensional approach. So we would need technological, environmental, geophysical, institutional, economic, and social measures to combat the challenge of climate change. And ADB is committed to fight this challenge. We have committed 80 billion over the period 2019 to 2030 as climate finance using our own resources. And we have furthered this ambition to 100 billion over the same period. So with ADB and other multilateral development banks, we lend our full support to fighting the challenge of climate change. With this, I would like to thank you for your attention and wish you all very fruitful discussions. Thank you.
谢谢 Sujata 女士的
Thank you, Madam Sujata. Madam Sujata pointed out that we need to, through the vaccination R&D, to respond to COVID-19, to provide a healthy environment for us, and we need also use innovative approaches to tackle the climate change. And in international cooperation, we should focus on the translation of innovative technologies and knowledge sharing, and promote international cooperation through the 6 dimensions of technology, environment, geography, institutions, economy, and social structure. Once again, thank you to Ms. Sujata for sharing. And now the floor is given to Professor Zhou Yuguang on the title of Explore Renewable Energy Technology Transfer Models and South-South Cooperation on Carbon Neutrality. He will cite some specific cases and practices in the transfer of renewables, including both challenges and opportunities. Before he begins, I'd like to brief you on his major experience. Mr. Zhou Yuguang is Associate Professor of China Agricultural University, a key member of National Center for International Research of Bioenergy Science and Technology, and a key laboratory of clean production and utilization of renewables. He specializes in renewable energy, biomass, bioenergy, emission reduction. And he has led some projects concerning the green energy. And he participated in implementations of South-South cooperation projects involving Sri Lanka, Zambia, Ghana, etc. A project launched by Ministry of Science and Technology. And now the floor is yours, Professor Zhou. Thank you, Mr. Moderator.
So good afternoon, good morning, delegates. So my name is Zhou Yuguang from China Agricultural University. Now I would like to make a brief report to all the participants on the exploring the renewable energy technology transfer models and South-South cooperation under carbon neutrality. And this is actually also on behalf of the team of China Agricultural University and China's Administrative Center for China's Agenda 21. So I would like to report the following 4 aspects. So for the carbon neutrality targets, just as mentioned a few minutes ago, actually carbon neutrality became a global neutral goal because more than 130 countries in the world already announced their carbon neutrality goal, and actually the total amount of GDP accounts for more than 60% of the global economy. So this is also very important for Chinese side and many developing countries. So this is really a good chance, and most of the goals among 17 goals are related to carbon neutrality. On the other hand, the Chinese president announced for more than 15 times since 2020 September that carbon peaking and neutrality development is becoming the national strategy of China, and also it is really taking into implementation. So this is also one reason that we have the driven force to achieve this goal, and this is also a good chance for us to work together with all the other countries. And on the other hand, we are carrying out some of the renewable energy technology transfer from China to many developing countries with the cooperation with the UNDP and Ghana, Zambia, Ethiopia, and Sri Lanka colleagues. So actually, during this work, we found that it is very important to study the local conditions. So here we would like to strengthen that the appropriate technology is very important. So actually, for renewable energy technologies, it's really it really diversifies in many forms. There are solar energy, and solar energy also can be divided into solar photovoltaic and solar heating and so on, and wind energy and biogas power generation, and geothermal and hydro energy and bioenergy. Currently, during the past projects, solar energy, biogas power generation, small hydropower, and the bioenergy are favorable by the partner countries. So first of all, I would like to briefly introduce the biogas energy technology. And actually, small-scale biogas developed for more than hundreds of years in China, and Chinese top leaders paid a lot of attention on the biogas development. So the left picture shows that Chairman Mao inspected a biogas digester site and watched how it is supporting the cooking. And the second picture is showing that the President Xi visited again a place that in Shanxi province named Liangjiahe, and this was the first biogas that he built more than 30 years ago when he was working there. And this is actually an example of crop residue utilization policies. This is also from one of our PhD student. Now he already finished the PhD study, and we can see that actually the crop residue turns into biogas or other type of utilization has a great chance through scores of year development. And for small-scale users, the household biogas digester technology now in China is very well developed, and we have standards, equipment, and also full of experience. And the total installation of household biogas digester in China is more than 40 million during the past few decades. And for large-scale biogas plant, actually, this is on one hand for the treatment of crop residue and animal manure and other organic waste. On the other hand, it can generate methane, which is clean energy and renewable energy, and also this is generally being combined with the power generator to convert it into electricity. And the fermented residue could be used as organic fertilizer. So the three pictures actually represented the different large-scale ones. The first one is for the pig manure farm, and the second one actually is for the for the dairy cow farm, and the third one is for the chicken breeding farm. So there are different scales, and some of the developing countries also are asking such kind of cooperation in this topic. And thirdly, for daily cooking in developing countries, the direct combustion of biomass is really important. However, it is a bad condition that some of the combustion is not that clean, and many PM 2.5 or other compounds might be inhaled by the people and affect their health. So Chinese clean stove sector has proper technology and densified biomass fuel technology, and also the equipment. So actually, many of the developing countries, they are asking such kind of technology and products for cooperation during the past few years. And the gasification of biomass and power generation, they have two routes. The left one is using the syngas, which is from the biomass gasification, and the other one is using the biogas from the anaerobic digestion. Also, it could support the demand in the electricity in developing countries. And for the small hydropower generation, we have to say that some data shows that more than 47,000 small hydropower stations has been built in China, and total capacity is 76,000 megawatts, and total annual electricity generation is more than 230,000 gigawatt hour. And we have to say that many of the African countries like Zambia and Ghana has been transferred with small hydropower technologies during the last round of the trilateral South-South cooperation project. And also the solar power generation, including the large-scale solar photovoltaic and the on-roof solar PV, and also the solar power plant that's using the phase transition material and power generation, also popular. But generally, the first two types are the favorable in developing countries. And for the wind turbines, we have also built different scale land-based and offshore wind turbines, and also the developing countries are looking for such kind of cooperation. On the other hand, we have to say that there are opportunities and challenges. Before saying that, for the technology transfer to developing countries, we found that the appropriate technology is very important. And secondly, it should be affordable. Thirdly, it should be accessible, which means that the feedstock or something the local conditions could fit. And somehow, besides that three A's, we will say that the fourth one is advanced. So some advanced technologies also under consideration. So that means there are a lot of opportunities and challenges during this kind of technology transfer. And we have to say that from Chinese top leader to different levels of organization, it's working very hard on the low carbon technology transfer. And also this is a really a good opportunity for both China and the other countries for the mutual low carbon transition. So during the past few years, the trilateral South-South cooperation technology has been implemented, and we worked with different countries like Ghana, Zambia, Ethiopia, Sri Lanka, and they are preferring to have the biogas, bioenergy, clean combustion, and solar PV and small hydropower technologies. So here are some of the pictures that below we can see the partners. They are very happy to get the new technology, equipment, and also we send the expert team for the local visits for investigation and technical training. So there are some barriers. We have to say that from the legislation level, like insufficient incentive for renewable energy development, and also some of the barriers in the IPR among different countries, and the technology aspect, even they have the technology, they could not produce. So we want to fill this gap that by inviting different stakeholders, including experts, investors, manufacturers, users, and also some of the universities and the research institutions, not only in China but also in the partner countries. On the other hand, to solve this barrier in the technology transfer, the financial support is really important. So the way of investment is really the thing that people spend more time for discussion, and also the large-scale production, which could reduce the cost, also rely on the modern technology. And also, we found that the enterprises are lacking of effective information, and the public interest in renewable energy is also a blank field. That is also a big challenge. So for the domestic part in China, also we need to let the people and the companies to enhance their internationalization capacity, because some of them would like to make good use of this chance, but they are not able to. So we organized some of the matchmaking events and some training programs to get them improved. So here are some suggestions. First of all, we still need to continue to promote the trilateral South-South cooperation renewable energy technology transfer. And here are some pictures, like the signing ceremony of the program, and the training. The second picture is the training, and the third picture actually is the South-South Cooperation Center and the ACA 21 that received international guest visits. And together we published some of the manuals for the technology and screen the technology with according to the targets from the countries, and make it online. And also we cultivate talents, like international students get master or PhD degrees, and we attend the South-South Cooperation events, and also some of the planet sessions. And here we also suggest that there are some results-oriented mechanisms, including top-level design, technical training, financial support, construction of market, should also be concerned. That should be taken into consideration. And in one hand, the financial support for the renewable energy technology transfer is really important. There are different sources, so actually we really need to have more interactions to think about it, how to make good use of these sources to support such kind of mutual goal. And besides, I would like to use one or two sentences to conclude that this is the team at China Agricultural University, and based on the State R&D Center for the international research of bioenergy science and technology. That is also by the sponsored by the Chinese Ministry of Science and Technology. So our group leader is Professor Dong. He is Professor Dong Renjie is actually the member of IEA TC Task 37, which is about the bioenergy, and ISO TC 255, that is biogas, and ISO TC 285, that is biomass combustion stove. So that is the international standard work. So we have many young professors working in this direction, and for the renewable energy and the rural energy in China and in many other developing countries. So here, this picture actually is the team of UNDP of Ethiopia, of Sri Lanka, and ACA 21 and the CAU to launch the second round trilateral project towards Sri Lanka and Ethiopia. So here, we would like to look for more of your support. Thank you. Thanks for attention.
好，谢谢周教授的。
Thank you, Professor Zhou, for sharing this knowledge and experience, and such valuable practices are very relevant for developing countries, develop renewable energy, and to combat climate change. I hope that all developing countries can work together to strengthen cooperation and find new pathways to develop renewable energy and also contributing to the global climate target. So due to the technical reasons, we have to cut the Professor Guan short. Now let's give the floor back to Mr. Guan. Thank you. Ladies and gentlemen, thank you for the opportunity. I'm so sorry because of the network issue. So let me continue with my presentation. So this is our database. Continue with Myanmar and Ethiopia. And I have also brought some reports, the hard copy. And you're interested, you can get at least hard copies, and I welcome for your comments. So this is about India. India is a major country in South Asia, and has a large area. So we tried our best to make a consistent analysis of India. You know, they have different states. It's like the provinces in China. And we also studied the central regions like the central cities and we understand emerging economies have some weak data, and the verification is really difficult. And we have done some work on the accountability and accounting of these resources and services. And we have some horizontal verification. So in some typical area, we studied the point source emissions, for example, refineries, the cement, but the data is quite limited. But they are the major emitters. So if we can collect the point source emissions, then we'll have a better understanding of the region and the country. We have finished 1,600 plus refineries and 5,000 steel making plants, and also over 5,000 cement plants. Meanwhile, we feed back these data to the inventory and the accounting work of emerging economies. With our work, we have cooperated with some major institutions like the institutions EUCA and the EU and IEA, and we compared with their data. Take Myanmar, for example, because of using their domestic energy data and the emission factors, and as well as some fossil fuel data. But for Myanmar, Uganda, they use a lot of non-renewable resources, and there's some deforestation in those countries. If we collect those data, the the statistics will be much larger than the available data, including the data calculated by EU and other major institutions.
In order to calculate the emissions for emerging economies, in fact, although each country is a small emitter, the combined value is alarming. For the total emission of the 60 emerging economies world, ranked number 3rd in the world. And they have great capacity in emission increase. In the future, it's very difficult for those small emitters to reduce the emissions. In that case, if we ask developed countries to contribute more to the GHG reduction, it's simply not likely to happen because the space is too limited for developed economies to pledge any more cuts in the GHG emissions. Let me conclude our work. First, China pledged to reach neutrality in carbon emission, and it was revolutionary. And it is of a great significance, no less than a third revolutionary. Smaller emitters have a huge potential of GHG emission. The pandemic lockdown will only slow down the emission, but they are still likely to become the next giant emitter. And in governing the global climate change, we need to pay special attention to the small emitters. And China should be given a greater role in bridging the gap between developing countries and developed countries and fully tap the potential, the emission reduction potential of smaller countries to give more explanation to the community with a shared future for mankind. Last but not least, consensus and integrity is the foundation of a global climate talks. For integrity or trust, a guarantee system, we may refer to the climate bills mechanism hosted by the UN to enhance the stability of a global climate governance. As the next step, we are going to increase the accounts to 150 countries in the next 5 to 6 years. Since 2016, the Ccus database was officially launched. And compared with our international counterparts, we are still starting up. And we hope to work with other emerging industries to improve the data sets to contribute to South-South cooperation in tackling climate change and the shift to low-carbon development. In closing, I want to thank you for your attention, and I wish this conference a success. And please also pay attention to our new release.
Thank you, Professor Guan. And I think no wonder he is the top climate change expert. He and his team has made a valuable report and data collection, and it's on a global basis. And according to their research, China and the emerging countries, how much potential they have, and how much what's the significance for all of us. So congratulations, Professor Guan. Yes, indeed, we have received your report. Congratulations on this valuable work. And I will thank all the audience for the first part of session 1. Now let's have a tea break, and let's come back at 3:30. Please enjoy the tea break for now.
请平行分论坛一的这个各位观众可以回到会议现场，我们的第二部分即将开始。
请平行分论坛一的嘉宾回到会场。
平行分论坛一的嘉宾已经在线上了，请各位观众回到会议现场。各位观众，各位线上的嘉宾
Ladies and gentlemen, welcome back to the second session. Now, first, let's give the floor to Gao Ling, researcher of Institute of Engineering Thermophysics of Chinese Academy of Sciences. And his topic is the role of fossil energy and its application in a carbon-neutral energy system. We understand that the Western world, especially Europe, is phasing out coal. But in China's case, we have a large amount of coal resources. And what will the fossil fuel going to play in the future energy mix in China? I believe this is a question of a common concern of relevant colleagues. So let's welcome Professor Gao Ling. Thank you, moderator. And I will thank the invitation. I'm sorry for my PowerPoint. So I have two versions. One is Chinese and the other is English. Can you read clearly? So I would like to share with you under the background of carbon neutrality. What's the direction of future energy system and the breakthroughs? And my topic is to build a compatible carbon neutrality and energy system. This is the outline. First is the technological pathway. Second is the main direction. And third is the building a carbon neutral energy system compatible with low carbon security target. And this is the first part. And we understand President Xi Jinping has made a pledge at the UN General Assembly for part Part of the reason is that it's the international trend, and the other is because of our interest and the lead. And that's why we need to work toward carbon neutrality by 2030. We have a carbon balance in the nature. We have the carbon source and carbon sink. However, due to artificial activities, the balance has been disturbed. Now we need to rebalance between the carbon sources and carbon sinks. So from the technological background, we need to calculate the carbon cycles and carbon intensities. We have three categories. One is carbon contented energy. Second is carbon neutral energy, like a biogas, because the biomass. Because biomass is from nature, so it will not add or deplete carbon. And third is zero carbon energy, like solar power or wind power. So based on the three categories, we have different technological responses. And we also have three carbon reduction roles accordingly. And the third part is CCUS. That's a major topic today. In the case of CCUS, we already have some available technologies, and some even play a new role. But I have to point out, actually, no single technology can solve this problem alone. Why? Why not? Because different technology has its limitations. Take energy conservation, for example. We have to make clear only by cutting carbon content energy can we reduce the emission of carbon. And currently, the coal-fired plant actually has a very high potential. So the potential for carbon reduction in this sector actually is very limited. And for CCUS, now it has a very high cost. In other words, each technological road has its limitations. So we need to have a portfolio or combination of different approaches. So for carbon neutrality, what will its system like? I think it should be multi-energy mix, like carbon content energy, low carbon energy, and zero carbon energy, and with corresponding technologies, for example, CCUS. So only by this multi-energy system and multi-technology coordination can we solve the problem. And this is our recent paper, and here I listed the main equation of the paper on this slide. And here we actually give you a clear expression or manifestation of different technologies. Now, in China, from central government to local government and even to the business sector, we have mapped out ambitious carbon actions. And different sectors have already issued their respective roadmaps. However, there is no synergy or coordination between provinces or sectors. And each sector or province only view or formulate their plans according to their respective conditions. And there might be some conflicts in the future. For example, the conflicts in the accounting. Maybe there will be some overlapping in accounting. And actually, this overlapping situation already takes place in some provinces. And there's some competition for limited wind power, solar power, and other renewable power. And the synergy is really a big obstacle for future action. And I believe that will be our future priority. Second is about energy technology switching. I myself work on the power generation sector. I noticed that in the last 2 to 3 centuries industrialization, we find there are three major changes. First is before or pre-industrialization. The human society mainly rely on fossil fuel to translate the heat power to power, to mechanical power, or from chemical power to thermal power. So that's the main issue for the primitive and agricultural society. However, with the challenges from the GHG, and in the next stage, we will have new challenges that it will be transformed from the thermal cycles to multi-energy complementarity and transform from concentrated energy sources to distributed energy supply. And we'll have solar to chemical power or electrical power to physical power, etc. So there will be a multi-energy transformation. And in the future, the energy system is featured by multi-discipline, multi-transformation, and multi-role. And that plays big challenge for energy storage. It can be concentrated and also be distributed. Take the charging station, for example. It can be a storage unit, but can also be a power generator at a certain point. So energy storage, transport, and transmission will have very flexible roles and will be switched easily in the future. In 2016, NDRC have put forward the goal of non-fossil fuel will account for more than 15% of the energy mix by 2050. And now we have the 2030 carbon neutral goal. And it is a big challenge because the renewable energy can be intermittent and it's not stable. For example, you cannot get solar power at night. So unlike the coal power, renewable energies are not that stable. And power is really difficult because it's difficult to store. So there will be a rigid connections between energy supply and demand, and there, especially in the power sector, fossil fuel decrease and the increase of renewable energy, it would bring double challenge or dual challenge to both supply end and the demand end. So these rigid connections will bring a lot of phenomena. For example, wind curtailment and solar curtailment, which is improving actually in recent years. However, on the supply side and the consumption end, when there is no match, there would be outage, which we witnessed recently, and also in Texas, USA, last year. So that's a result of this double vulnerability at both ends. Now let's look at some main themes of energy. In the last century, the keywords are efficiency and clean. But these two actually are sort of a paradox. And now another keyword is low carbon. And it's become more and more popular. However, another keyword with the increasing use of renewable energy, from like 10% to 30% or 4% or even to 100%, as some scholars suggest. Are they safe? Is it safe? So for the future energy system, the main conflict is between low carbon and safety. So what are the most difficult challenges? The 4 keywords, I believe, will be ranked, like safety, low carbon, clean, and efficiency, instead of the other way around. For example, I believe in the future, renewable and resources will be cost-effective enough, and they are negligible in terms of the cost. So in the future, when the cost is low enough, we don't have to consider about efficiency. So against this background, how to build a carbon neutral energy system with no carbon and safety compatibility. So here are some 3 main road pathways. One is the low carbon use of high carbon energy. Second is the safe use of zero carbon energy. And the third is systematic integration of carbon neutral energy. So, and this will become even more important in the future. Carbon neutral, as I mentioned before, is a systematic work. So here I would like to point out 2 technologies. One is CCUS. CCUS is the only technology solution to use high carbon energy in a no carbon manner. And from the theoretical side, fossil fuel actually are exhaustible, and CCUS can actually reduce the carbon in the system. The obstacle in the past is high cost. But after the carbon neutrality goal is released, and this cost issue is no longer an issue, because we have to reduce the cost, and the fossil fuel has to be phased out. And that's why CCUS has to become even more important. So with the support of ADB, we have issued this report, and we have made new predictions of CCUS, and pointed out we have some window opportunities to grasp. And for hydrogen technology, because hydrogen is closely related to carbon resources, so I believe it's another solution. Its materials are widely available, and it has integration between storage and application. So hydrogen technology can play an even more important role in the future energy system. From the production end, it can solve the volatility problem, and on the consumption end, it can make the rigid connections flexible, and can make a flexible transformation from hydrogen and electricity. So these are 2 suggestions. One is the integration system. Second is carbon integration. Thank you.
Thank you, Mr. Gao, for your wonderful speech. Your presentation is very informative, insightful, and thought-provoking. First, low carbon and sustainable development is compatible with each other. And the hydrogen-based transition is a highlight. And CCUS, and its choice, has to consider many factors. And it's a matter of life or death for many enterprises. And we are happy to have with us a researcher, senior principal researcher, Mr. Kim from KBIA, Korean Battery Industry Association. At another forum of ADB, he was also invited to talk about the EVs, or electric vehicles, in Korea. And today, we are going to invite him to give another speech on the recycling of the used batteries of EVs. As EVs in China is gaining momentum, the used batteries will be the next challenge for China. So I look very much forward to Mr. Kim's sharing. Mr. Kim, you have the floor now.
各位嘉宾，不好意思，稍等一下，我们这边掉线了。
Pictures, you can see our process buildings and some reliability and safety buildings. So I will tell you about our details, our experience about the reused batteries. This is an introduction about the second use batteries. We say this is a second use optimization because the EV car, they are the high performance of the battery characteristics. So the battery lifetime is limited around less than 8%. So the first life came starting from the 100% to the 8%. After that, we can use more lifetime for use less performance application like the energy storage system and other street light. So we are considering how we can use for the second life battery to our industries. So we said this is also used from the EV cars. After end of the life, then we can use the energy storage system in mobility and street light and U-shapes, because there are some benefit to reuse, to recycling. We can reduction the cost of the 30 and 50% of the battery cost, and also the battery cycle life is extended more than 10 years. Then we can prevent the environmental problems. Also, recently the ESS application is much more cheaper than other applications, but we are using second use batteries, then cost will be down to 30%, and also the calendar life less than 50%. So approximately it can save the 40% for the cost and everything. And also we have another benefit for environmental friendly. Actually, the battery can be used more like around 5 or 7 years than after then they will go to the recycling. But we believe the for environmental friendly application can use more life, and then they go to the recycling. Also, the low carbon environment societies, they are already finished the carbon footprint in EV car. So aerosol system, they don't need the more carbon footprint, just need a small size capacity goes to assembly. In case of Korea, we are expect to the 8,000 EV batteries can out from the market. After then, we expect more than 200,000 EV car battery will be go to the recycling. So we hope it can be possible to use another application from the 2023 and 2030. This is a global EV battery demonstration. So you can see that many countries can operating the second life battery for another application, like to the storage right and large scale power storage and storage system and EV chargers and mobility house and energy storage system and backup power elevators, solar energy storage management, EV chargers, and also the data centers. In case of Korea, we are starting to do this R&D activity in 2015. So the Hyundai Mobility, they have some extra battery for after the battery EV cars testing. Then they are using this car who use another application like the energy system. It can include the 28 kilowatt hours PV packs can accumulate 218 kilowatt hour for the Hyundai steers. Also, we have the challenge to use the hybrid system. That means the user battery combined with the new batteries. So we have to design for the EV car from the EV electric bus, and we can combine to the new battery with second use batteries can supply for the electricity to the buildings. Another challenge is the EV chargers. So you can see the several EV car battery packs from the I3 Jeju Island. We are accumulating and converting to assembly to the EV charging station. So it can be possible to charging the EV cars. This is another application of the UPS for the telecom stations. So we have several experience of those since 2017. So Hyundai Stellantis system, EV chargers, just say substation UPS, energy dream centers, EV station, and we have some small energy system for using various kind of the EV cars. This is our process design of reused battery early publication. 2017, we are starting small energy system and UPS and EV chargers, and then it will be spread out to the more application using the energy EV batteries. So we can expect second life battery application will be go through to the small mobility and stationary system, depend on the battery capacity. We are constructing our new facility in the larger island, so larger province. So you can see that some our process line, it can process around 1,000 EV car battery per year. So I will introduce more detail about the process design and facilities and equipment. Also after that, we need some reliability and cycle life verification and EMC verification and safety performance testing facility like the reliability, environmental tests, and safety tests for the second-use batteries. We are make our own definition about the reuse, republication, and recycling. So this is a full life of the second life battery, end of the EV battery, or end of the energy storage system. After that, after the finished life, first life, then we can test into our battery packs, and then we are creating to classification for like the class A. That means the capacity and SOH is higher than 80%. It can be possible to the reuse, including the EV cars, EV bus, and other things. Also, the less than 80% and higher than 65%, it can possible to the republication using energy storage system and e-mobility and through rides. But finally, the less than 65% of the batteries, it goes through to the recycling. So it just to getting from some materials, lithium and cobalt. Cobalt will go to the battery manufacturing. But you know that this whole process will lead to some research activity about how we can test in the packs and modules, how we can design to the BMS, how we can approve the certification for the safety and performance. That is our main activity to researching the second-use batteries. So this is our process design for reusable publications. So after that, after end of the life, the battery can separate from the EV cars. We are registered and we make some RF tags and experience outer expectation. We go to the test. That means OCV, isolate resistance, capacitance, HDC resistance, and self-speed test can be possible to the grading like reuse, republication, and recycling. But the testing sequence will be separated by to the pack and modules, and then we are make some functions to how we can evaluation and verification about the reuse, republication, recyclings.
Mr. Kim, just a reminder, you have only 4 minutes left.
Of the from the warehousing to the factories. So you can see that some warehousing process we are carrying on the battery packs and go through the washing and some appearance test, and then go to the electrical test, and then we'll go to the evaluation for the pack size, and then go through to the disassembling to the module size. And after that, we separate each modules. We'll go to the residential test and SOC test, and OCV test go to the warehouse. During this test, we are selection to some grade C. That means the rest of the 65% of the capacity and SOH will go to the recycling. But in this process, we have still more 9.5 hours to evaluation for the battery packs. There are several technology to evaluating the SOH, SOC, SOP for using the charging and discharging, resistance test, and full charge discharging, and half charging, and various kind of the test method will be applied for this evaluation. You can see the more detailed process. We are made our own manual process to warehousing, package inspection, and package electrical inspections. This is our facility to test our pack inside of the chambers. After we are analyzing the test result, like pack test and module test, and some kind of the data analyzing, and we can to classification about grading of these EV battery packs. We also have to the economic analyze into the reuse and recycling. In case of the 2017, we are get the 12 EV battery user batteries, and then we have another source from the hybrid batteries can around 3,600 EV battery pack go out to the EV cars. But you know that the hybrid battery system is just 1 kilowatt hours. That means the 3 megawatt hours battery packs go out from the hybrid cars. Also, the 12 EV user battery, it had around 300 kilowatt battery packs. But 2020, we have to 1,400 EV car batteries go out from the EV cars. Also, the 19,000 hybrid battery cars go out through the hybrid cars. That means is to the 90 megawatt hours battery pack from the hybrid car and 300 megawatt hours battery pack from the EV cars. Actually, before I mentioned about the size and capacity will be increase more than more people. This is our current state of the end of the life battery packs. The recycling will go to we'll just to get the lithium and cobalt, some manganese and other things. But the second life, there are besides before the recycling, we can reuse republication around 5 or 10 years for energy systems to right. It's calculating to the adapting to the energy storage system price around $250 per kilowatt hours. That means that $91 billion per can get benefit from the second life. Also, we spend more process cost and some other things, but we can make the profit using the extra profit economic benefit from the second life. After that, it's same tons and same price of the recycling. I introduced our recycling industry in Korea. Before, in 2015, I calculating our recycling industry supply chain. So almost supply chain and produced by sourced from the domestic 1.4 tons, and we can import it from the overseas. This is around 1.3 tons, and just extra came from the 1.7 tons. Then go to the material disassembling, crushing, and hydrometallizing. It can producing to some previous materials like the cobalt sulfate, nickel metals. Then we can go to some using for the battery industries. Also, the current process is just simple to like the collection, physical treatment, and chemical separation and purification. And after that, we can use the metallization. So lithium battery go to the raw materials. This is some photo to the current process of the waste battery, lithium polymer battery goes through to some raw phase, discharging, dehydration, drying, crushing, and magnetic separations, cleaning, dust collection can go to some metals. Also, we are other application about to the hydrolyzing, wrenching, filtering, and then solvent tank, and solvent extraction, crystallizing. Then you can get some previous materials. for the lithium batteries. We are thinking to another new clean recycling plant. So before I mentioned about our facility will use to reuse for the grade A and B, and grade C will go to the recycling. But recently, the U.S. government was supporting to the clean recycling technology. So resale, they are just collecting the active material from the electrode. Then it can go to the republication by cathode materials. Also, we are planning to another facility in the Gwangyang areas. We are starting this project in this year. So electrochemical recycling process will be developing this facility. That means just disassembling cells, and then we separating the electrolyte, current collectors, and cathode materials. After that, we need some metal collection process to separating to the lithium, cobalt, nickel, mangan, and graphite. And then also we can get some oxidation materials. After that, we are physical evaluation. So they don't need any metallizing treatment and other things. Just simple process to get the raw material can be possible to the republication by cathode materials and anode materials. So in our business model, we'll go to like this one to Jeju Island, and Naju will send to the end-of-life battery go to the Gwangyang, and we will make this process more clean technology to use the recycling. I hope this reuse, republication, recycling will help to the clean environment to use to expand our lithium battery technology. Also, we hope to see you. I hope to introduce more detailed, real-time processing to the reuse republication in next years, because our facility will complete the construction in next February, and then we will process the more than 1,000 EV battery packs to use the republication use in end of the next year. Thank you.
Thank you, Mr. Kim, for sharing. I think many DMCs will benefit from your comprehensive and knowledgeable presentation. Thank you very much. 近年来，我们这个氢能
So in recent years, hydrogen energy has been particularly popular in China, especially after President Xi made the pledges. A lot of governments, businesses, and associations are highly actively participating in hydrogen energy development. So what are the key technologies, and what are the breakthroughs we need? Now we are honored to have with us, researcher Xiong Yaling, to discuss the strategies of China hydrogen development. The floor is yours. Sorry, the speaker has muted her mic. So my topic today is the strategy and technology roadmap of China's hydrogen energy industry. This is the outline, the classification, driving force, and development trend of hydrogen. Second, China hydrogen energy outlook. Third, the key technology and economy. The first part. First, the driving force for the development of hydrogen. Now, we can see the global hydrogen energy has a strong momentum, and it has taken.
肖老师您好，就是我们这边字比较小，请您把 PPT 调出去。好的，辛苦您了，谢谢。
啊，行，好的，不好意思。那么中国呢，也是即将。
China is one of the 11 countries to release the hydrogen development and expected to release it early next year. In 2020, it's a big year for the development of hydrogen. And there are three major driving forces. One is the energy security. Japan is a typical country to develop hydrogen. Second, the driving force is economic growth, led by Russia and Australia, the resource-rich countries. And the third is EU-led, and its major driving force is decarbonization. So for this trend, this round of development, we can see marvelous momentum. So from this slide, you can see decarbonization has become the first driving force. China also announced its carbon neutrality by 2030. So unlike ever before, this round of development has seen more and more momentum, and we believe hydrogen is the only way to achieve carbon neutrality. By the end of 2020, there were about 118 countries have pledged their carbon neutrality target, and 17% of the countries actually have already made the commitment. Take China, for example, on September 22nd, President Xi Jinping made the carbon neutrality pledge. In the same month, 5 ministries have issued the notice on the demonstration of fuel cell vehicles, and we will adjust the subsidy policy to purchase of fuel cell vehicles and reward eligible city groups. So from this information, we can see the hydrogen development has received attention from across the globe, and actually it has become a global consensus, and the clean hydrogen has been regarded as the next big thing and will become a new energy commodity. And this is our alliance standards issued last year. This is the standard and evaluation of low carbon hydrogen, clean hydrogen, and renewable hydrogen. So if it is below 14.51, it is regarded as the low carbon. And if it's below 4.9, it is regarded as a clean hydrogen threshold. So we can benchmark with all these thresholds. Take EU, for example, the newest standard is 4.73, which is lower than the clean hydrogen threshold in China. And according to EU, only renewable energy turned hydrogen is called clean hydrogen. Currently, the global demand for hydrogen is 115 million tons, almost all of which comes from fossil fuel. And low carbon and clean hydrogen is less than 3%. And the installed capacity of P2X projects and operation and construction is 151 megawatt. 16.5% is located in Europe, and 25.8 gigawatt are under plan. And this shows the number scale of planned projects is increasing significantly, but mainly located in Europe and Australia. And even the scale of a single project is increasing from several megawatts to 100 megawatts. From the technology aspect, in the recent 2 years, we can see alkaline and PM water electrolysis jointly dominate the market. And PM projects have increased significantly in recent 2 years, but large P2X projects are mainly alkaline. For electrolysis, in foreign countries, we find that it's mainly in the industrial sector, for example, chemical sector, and other transport and power sector. Australia is a typical example. It has a major exporter of hydrogen. In terms of end use, take transport for example. By the end of last year, China has about 8,000 FCVs. That's about 23% of the global total. And China is also the largest commercial vehicle market in the world. There were about 128 hydrogen stations, ranking second in the world. And the application of hydrogen in industry, construction, and other fields is developing rapidly. Take construction, for example, hydrogen is used for heating. For example, in Canada, USA, and Western Europe. There are about 40 demonstration projects. We also have E farm cogeneration projects in Japan. In terms of industry and power generation, USA and ROK are the major countries for the large distributed fuel cells. Japan is also working on the hydrogen to power demonstration projects. And Europe is mainly working on the hydrogen metallurgy and the reduction process. Next, let's talk about the outlook. This is the China Hydrogen Energy Outlook released this year. And I believe it's important for us to know the picture, the status quo of hydrogen production and consumption in China. Last year, I don't think we had a clear idea. And there's some myths in this industry. The consumption is about over 20 million tons. And for the very first time, we had a more accurate number, which is 21.24 million tons for production from coal and 4.6 million from natural gas and 7.08 from the byproducts of industry processes and 500,000 tons from electrolytic water. As for the end consumption, it mainly go to the downstream industries. For example, to produce ethanol and also in the petrochemical, refinery sectors. And also a small part in the transport sector is only about 0.1%. This is our projection of hydrogen demand outlook under carbon neutral scenario. In 2019, we made another outlook projection, And then we made another one under the hydrogen, under the carbon neutral scenario. And we believe that the amount will increase from 30 million to 130 million tons. And in terms of end consumption, the total consumption of hydrogen will account about 20%. And the industrial hydrogen use will still take lion's share, about 16%. Transport will use about 14.51 million tons. Construction 5.85 million tons. And many it's in the heavy duty transport. And the main technology path will be the EVs. In 2035, we believe we'll have 1.2 million FCVs, and there will be more than 10,000 hydrogen stations. And by 2016, the heavy FCVs will count about 65% in the passenger car field. It will count about 15%. I believe our estimation is kind of conservative. According to other estimation, it can be as high as 25%. And I believe based on the combination of fuel cell and electrification, the transport sector may achieve net zero emission by 2050. And now let's look at the industry, construction, and electricity decarbonization. And we believe in the industry, especially new feedstock, we have a lot of new demand. And for example, the aviation demand fuel, and it can also use as industrial fuel for iron making and for cement. In terms of electrification, it will mainly used in the medium low end. In building and power generation, technologies such as hydrogen blending with natural gas, hydrogen burning boiler, and gas turbine are used to realize decarbonization. So this is the demand and supply structure. In terms of technology, currently hydrogen is a secondary energy. The cost is low, so but has a high carbon emission. So we need to use CCUS. So we need to work on the hydrogen purification technology and the water electrolysis technology to reduce the cost. And it has a high requirement for the purification. So this is the roadmap for green hydrogen technology and economy. Here we listed the main milestone and the technology importance. Now, in terms of economy, we have mapped out this levelized cost of low carbon H2 and clean H2. Currently, the cost is between 23 to 28 yuan per kilo. And the cost of PEM will be about 14% higher. And the cost of low carbon H2 with CCAs is about 15 to 27 yuan per kilo, which is slightly lower than the cost of renewable hydrogen. And we use this cost analysis. The key cost reduction factors is efficiency, equipment cost, and service life. And it can cut the cost dramatically with a key technological breakthrough. From a technological perspective, the key of AE is to improve the current density, and PME is to comprehensively improve and optimize the performance of the three. So it leads a comprehensive improvement. And this is the technological gap between China and advanced countries from the perspective of AE, PME, etc. And we can see we are lagging behind from EU and other advanced countries. And those countries have accumulated a lot of technologies. And in China, we're still in the nascent stage and don't have sufficient data. Overall, we believe in the future, with decreasing power generation cost, we believe by 2025, LCOE is expected to reach 0.3 RMB per kilowatt, and LCOH is expected to reach 25 RMB per kilo hydrogen. And it will be able to compete with MR. To conclude, I would like to refer to our work briefly. And currently, we are a platform with multidisciplinary. We work with ministries, research institutes, we work and think tanks. We can do industrial eco system, work out standardization, and work standard testing certification platform, and also we serve business incubation so as to contribute to the future hydrogen development. This is our report. Thank you for your attention.
Thank you, Researcher Madam Xiong. From your speech, we know that under the carbon neutrality, two key technologies in generating hydrogen, as well as the future prices of hydrogen, would be comparable with the gas and natural gas and coal. And our next keynote speaker is Professor Zhang Xia from Sichuan University on the biomass technology and its applications. I guess coal-based oil and bio-oil are concepts that you're familiar with. Coal-based oil initially comes from fossil fuels, but biofuels are green. So how to convert biomasses into biofuels? That is the key question. Can it replace the traditional fuels? If yes, when will it replace traditional fuels? Now let's listen to Professor Zhang. Can you hear me, ladies and gentlemen? Yes. Honorable guests, dear colleagues, ladies and gentlemen, I'm with Sichuan University, Zhang Xia. I'd like to thank ICCA 21 for the invitation and the opportunity to share with you some of the work of my team. I have heard some insightful presentations just now, and my presentation, however, is more focused on the micro technologies and stand to be corrected. My report is going to cover 3 parts. First, the background information. As China pledges to achieve carbon neutrality by 2060, and Tsinghua University mentioned a combined approach to reduce carbon and increase the storage of carbon underground. Together, we are going to work for a carbon neutrality in terms of resource-based carbon reduction. We can fully leverage biomass waste, biomass, and CO2 as raw materials to replace fossil fuels, to convert fossil fuels to shift from fossil fuels to a secondary energy in the underground. That is, we will gradually decrease the carbon emission from fossil fuels. One of the 125 most front-running scientific issues in the world released by Science is that what kind of energy can be used to replace oil and when. According to a UN forecast, by 2050, the world population will hit 9 billion, which means a 60% increase in grain output and 40% of new demand for energy. That means a huge demand, and we need to shift from fossil fuels to waste straws. Waste straws is a massive source of biomass. Its combustion will cause severe air pollution. However, it can also be converted to biofuels with high value. It represents a pace setter in the converting of biomass into biofuels. And biofuel controls, there is a green premium for biofuels. From this table, we can see that compared with fossil fuels, biofuels can better control the premium in its green production, and it has a better prospects for industrialization. Currently, their output of a waste straw is 900 million tons per year in China, while China relies on foreign supply in its petrol supply. If we can convert waste straw into biofuels, that would be a huge contribution to the energy independence of China. From this map, we could see that the output of grain overlaps with the petrol refineries in China. If we can develop a joint refining of waste biomass and petroleum, it would be a great idea to achieve a cross-sector integration of industry and agriculture, therefore greatly reduce the cost of fuels. However, one obstacle is that the water content in biomass is very high, up to 80%, and high oxygen content up to 50%. That means it needs to dry pyrolysis and deep deoxygenation before entering refinery. Well, there are difficulties because high energy consumption for drying and pyrolysis. Oxygen-containing groups are easy to polycondensate, resulting in catalyst coking and deactivation, and long-term operation of the device is difficult. After years of research, my team has been concentrated on breaking the bottlenecks, and we have made some ground breakthroughs in the technology and equipment for straw to biofuels. First, we use waste straw as the raw material. After non-phase change drying and pyrolysis, we can derive a pyrolysis solution through full component hydrogenation. By adding deoxidizer and hydrogenation, we may generate gasoline, biogas, and biodiesel. Here are the detailed information about the manufacturing process from waste biomass to biofuels. As for the difficulties mentioned above, we developed a non-phase change drying and pyrolysis technology and equipment. Our goal is to establish a 10,000-ton scale non-phase change drying pyrolysis. Currently, we succeeded in developing a non-phase change drying technology with a capacity of 50,000 tons per annum, and experiments show that between 60 and 80 degrees Celsius and within only 10 to 20 seconds, the moisture content of the straw decreased from 37% to 10%, and the energy consumption is 80% lower than the traditional rotary kiln. As for the biomass, currently we developed a down-bed pyrolysis pilot plant for solid heat carrier with a capacity of 50 kilometers per day. We want to study the straw pyrolysis yield, composition, and chlorine migration. In order to solve the problems of polycondensation of pyrolysis liquid, coked and deactivated catalyst, and the fixed bed is apt to be blocked, we created a fully mixed flow fluidized bed reactor with high dispersion and fast heat and mass transfer to delay coking. We also developed a high-strength, wear-resistant, multiporous carbon catalyst and innovated catalyst in situ regeneration technology to delay the coking of catalyst. Currently, we have built a high-strength catalyst carrier production line with a capacity of 20 tons per year, and experiments show that anti-coking carbon sphere catalyst production, the porous functional carbon spheres prepared based on microfluidics, can meet the high mechanical strength requirements of the catalyst in the fluidized bed reactor. As for the catalyst in situ regeneration technology, we also developed some mock device and a self-revolution detection platform to reveal the mechanism of particle self-revolution, inducing catalyst micro-interface vibration to remove coking precursors inside and outside the pores. And the results show that the catalyst's life can be prolonged by more than one time. Also, we have built biomass pyrolysis, deoxygenization, and the fixed bed hydrogenation pilot equipment. The project has been in stable operation for 3 months with a deoxidation rate of over 99%. And you can see the pictures of the fluidized bed, down bed pyrolysis, and fixed bed as well. From our analysis, we find that the pyrolysis of straws are really complex because many side products and chemicals were produced. Also, we find that some chemicals are outnumbered than necessary. And after the pyrolysis, we will get a biochar or the residue. Almost 20% of the biomass. The landfill has only a low added value. In order to increase the added value, we developed a series of biochar-based composite materials to absorb PM 2.5 and GHG. Let me give you one example. Using the carbon and silicon source in the residue, carbon zeolite composites was synthesized in situ by alkaline fusion, dissolving silicon, and hydrothermal method. And its CO2 absorption capacity was greatly increased from 1 to 1.5 mmol per kilogram per gram. Last but not least, we have cooperated with Sinopec to establish a whole project and constructed a low-cost, deep deoxygenated biomass fuel technology system, built a 10,000-ton demonstration project, and form a million-ton class process package with proprietary IPR, with biomass value added to more than 2,000 yuan per ton, biofuel cost 4.84 yuan per liter, and carbon dioxide reduction by 66%. This project has been awarded a funding by the country and has been listed among the national key research projects. We also established an integrated refining with refineries. By collecting the waste straws from across the country, we would put them into a pyrolysis device, adding where they will be pyrolyzed. And this will be followed by the oxidizer and refineries. What about the economic analysis? This is a map produced by Iowa State University. The joint refining of biomass and the refineries can greatly reduce operating costs, greatly reduce energy consumption of non-phase change drying, and the residue catalyst with higher value. This will further help reduce costs. So it's really cost-effective, and it's promising. During the 14th five-year plan, we hope to start a project in Sichuan to produce 1 million tons per year of energy chemicals out of waste biomass in cooperation with Sinopec and East China University of Technology. We are also having talks and negotiations with local governments and some investment group. Apart from straws, animal waste also contain a lot of cellulose or semicellulose. That means they can all be used as raw material for biofuels as an alternative to petrol. With regard to the conditions in Sichuan, the province is rich in biomass, yet it relies on foreign supply in petrol. And the province is a great producer of rice wine. That means that there is a lot of rice wasted from breweries. And the province is a huge consumer of electricity. And 80% of its consumption of petrol has to be reliant on foreign supply. That means the energy consumption outweigh its supply. Hence, the need to produce from biomass biofuels to complement with the province's energy consumption. In closing, under the vision of carbon neutrality, we will work together from a fossil fuel based system to a renewable-based system. That means that we will shift from the CHO system to the CH system. For our part, we hope to convert waste biomass into high added value biofuels. And through the carbon neutrality mode, we hope to facilitate industrial restructuring, improved energy mix, and for high quality development. Before I go, I'd like to introduce to you some of the actions taken by our university. In March this year, the Ministry of Education, together with a number of other universities, unveiled the targets as well as some plans for education, personnel training, etc., with a focus on low carbon development. On April the 10th, 2021, Sichuan University led the inauguration of the Sichuan Carbon Neutrality Technological Innovation Center. And academician Hao Jiming was nominated as the head, together with another academician, Mr. Shi Bi. And Tianfu Laboratory was unveiled in June this year. And our university was also approved to offer a doctorate program. In closing, I want to thank the support of the National Key R&D Project of Ministry of Education and all the supporting departments. Thank you and welcome. I would look forward to your visit to Sichuan. I look forward to see you and work with you, have more consultation, negotiations with you. Thank you.
Thank you, Professor Jiang. Thank you for the perfect timing. For introduction, we have a bad understanding of the work of your team, which focus both on theory and on practice. We look forward to more breakthroughs and demonstration projects from your team, so that biomass can play an even bigger role in carbon neutral. Thank you. Now, next, we'll have Professor Wang Tao from Zhejiang University, and his topic is Development Roadmap of CCUS in China. So CCUS is carbon capture, utilization, and storage. It's an important technology for carbon neutral and is receiving more and more attention. And my department also have a lot of approaches to consult all these CCUS technology, especially its application in sectors which is difficult to decarbonize. And China is an international leader in CCUS, which has everything to do with government support. So under the carbon neutrality scenario, CCUS, what is the role? And is it like the magical cure for fossil fuel? Or is it a silver bullet for low carbon development? Now, let's hear the insights from Professor Wang Tao. Thank you, moderator. And also, I will thank ADB and the ACCA 21st for the invitation. So I will talk about the development path of CCUS technology in China. This is the outline. First is the positioning of CCUS. Second, the maturity and the potential of CCUS in China. And third is the outlook. According to IEA's report, the IEA ETP 2020 report, energy efficiency, renewables, and CCUS are expected to contribute a lot to the carbon neutral scenario. And they will account for 15% in case of CCUS. Take China, for example, with the fossil fuel when the main energy resource for long term, CCUS will become an important component of the technology portfolio for carbon neutrality targets. and with huge potential for future emission reductions, considerable room for cost reduction, and a variety of technology development pathways. So these pathways is quite diverse, and application is also can be widely applied. And from this requirement of carbon neutrality, we can see the emission from the energy system accounts a big part, actually the largest part of the emission in China. And due to the current energy mix, as well as the use of fossil fuel in various sectors, you can see from 2020 to 2016, we need to reduce the emission by a large margin. We need to reduce the use of fossil fuel by a large margin too. By 2016, according to the dual carbon targets, we'll still use about 20% of fossil fuel, and it will emit about 2 billion tons of carbon. So in order to achieve carbon neutral, CCUS is critical. And it is conducive to transform the traditional fossil fuel sector to new energy in China. So we need to build such a technology system, and it can include zero carbon products, elements, and factors, and some negative carbon technology. So this slide is about the carbon sink potential of China. And currently, China's terrestrial ecosystem have a carbon sink potential of 0.7 to 1 billion tons per year. And of the stationary sources of CO2 emissions for energy industry is about 2.8 billion tons per year. If we still use coal-powered plants, and if we take consideration of the sink of CO2, which is about 2.8 billion tons per year, which can be geologically sequestered. Coal-powered plants and CCUS can work together because it can first guarantee the power security, but also can help to achieve carbon neutral. Iron making and steel making and cement is two of the major sectors that can have good CCUS application, because the total emission reduction can contribute about 31% and 25% respectively. Next, let's move on to the maturity and the potential of CCUS in China. Currently, from the global perspective, there are about 16.5 commercial CCUS facilities, of which 6 are located in China. And it can sequester about 13 million tons per year. It's quite huge. So of the 73 CCUS pilot projects in China, we have accumulated a lot of good experience. Currently, CCUS is mainly in the coal, mining, power, and cement sectors. And the application of CO2 mainly involves the EOR, ECBM, and EUL, mineralization, chemical utilization, and we also have some piping pilot projects. So as I mentioned, we have a lot of potential to tap theoretically, but due to the maturity and the economy of the key technologies of CCUS, a lot of potentials cannot be released in short term. So we need more policy support and incentives, but it is expected that by 2030, China's CO2 capture potential can reach 585 million tons per year, and comprehensive emission reduction potential can reach 170 million tons per year, and the total potential of storage or sequestration will reach 160 million tons per year. So technology readiness, I think capture is an important link. It has a direct bearing on the maturity and the cost. So here we have the cost as the Y and the potential as the X. Currently, the cost and scale is demonstrated in this slide, and we categorize it pre-combustion and post-combustion. By 2030, we believe there will be large capture potential with lower cost. And for the post-combustion solid will lead to cost reduction by a large margin. By 2050, the technology will be further developed. The post-combustion solid membrane separation and oxygen enhanced combustion, or OEC, will have a great potential to tap. Chemical looping combustion, or CLC, will also have great potential to offer. So this is the technology readiness analysis. Currently, China has mapped out a series of policies and plans, including the National 13th Five-Year Plan and the National 15th Five-Year Plan on Science and Technology. CCUS have been included in both plans. In the future, when looking at CCUS, and in terms of the generational turnover, we can see the first generation of CCUS is expected to transform from the second generation and reduce the cost from 400 to 300 per ton. And this is the photo of Jilin project of National Energy Group. And this project is undertaken by Zhejiang University. And we have built an ongoing CCUS pilot project. And this is currently the largest one, with 115,000 tons per year. And the CO2 capture rate can reach 99%, and CO2 purity rate can also reach 99%. Both are very high in China. In terms of CO2 utilization, we believe it is the ultimate goal of CCUS. And we suggest to use some mature technology based on local conditions. And we have projects in Inner Mongolia, which can reach 10,000 tons per year And we can also use the spirulina flakes and other bio resources for carbon capture. And this is the CO2 mineralization project. We can use this project to form carbonated lightweight concrete, and it can help us to use 10,000 tons CO2 per year. And this pilot project is located in Henan province. So, in China, we already have some commercial projects for CCUS. And this business model is the key to reduce the cost of carbon capture. A viable business model can rapidly reduce the costs. I believe there are 4 models. In the early days, it's SOE model, because currently most CCUAs are taken by the state-owned energy groups or cement groups, which has deep pockets. But in the future, especially in the second generation pilot phase, we can use the JV mode. And in the early commercialization stage, you can also use the transporter mode and of CO2. And when the technology is getting mature, can use CCUS operator mode. So we believe we can have a few CCUS industrial clusters across the nation with lower cost, large scale, and we can make better use of oil and natural gas. So with large-scale piping and transportation, we can have more economical use of CCUS. But that lead reasonable planning and long-term application. For example, can use in the different basin, like the basin in Xinjiang and Sichuan, and in the Mongolia, etc. So this is my presentation. Thank you.
Thank you, Professor Wang, for sharing. CCUS in the Asia-Pacific region is most lacking in a large-scale pilot project. Based on such a pilot project, we can improve the details of our technology in order to reduce the cost. On the part of ADB, we will continue to support the CCUS and the utilization and BECCS, DEC, and air quality capture, as well as a business model. I hope we can further work together to facilitate the technology towards the drive of the dual carbon target. The previous presentations have been focused on different special fields in the large area of the low carbon technology. As we know, low carbon or zero carbon actually involves a wide range of topics. And now let's hear a different voice from our sphere. Madam Sun Yan, about the topic of the global research landscape of low carbon and zero carbon. Welcome. Thank you, Mr. Moderator. Experts, dear colleagues, good afternoon. I'm really honored to be the only offline presenter, and I'd like to thank the organizer for the invitation, and I'm really happy to be here in this beautiful city, Changsha. I've heard many wonderful and insightful presentations, and for the time allowed by me, I'm going to explore with you the pathways to net zero global research landscape of low carbon and zero carbon technologies. My presentation will mainly cover 4 parts. First, introduction of Allocation. Second, global research on the low carbon sector, as well as the hot topics. And before I close, on some actions by Allocation. Those who are familiar with Allocation may know that the history of Allocation dates back to 400 years ago. At that time, scientists like Galileo would take Allocation to publish their classic works. So we have a history of over 400 years. Over the past 400 years, we have cooperated with over 180 authors of the globe and over 25,000 institutions to publish many journals. For example, in the applied medicine, the Lancet started in more than 200 years ago, and for life science, the journal Cell has a history of 5 decades. For physics, we have the field, and many fields. Experts in the field of fuels may also be familiar with this journal. And for the low carbon research, we have also offered a platform for your publishing. And we have a Ccus, the largest database for research, providing strong support for your research. Over the past 400 years, the original mission of Allocation remain unchanged. That is to benefit mankind by facilitating research. With climate change and COVID-19 still raging, we hope to contribute our due part. As the largest global research service provider, Allocation has been a leader in providing data analysis for researchers. And we have offered special analytics, for example, for US, China, Europe, and Southeast Asian countries. We offered scientific assessment and evaluation, and also offered data support for global university rankings. For example, Ccus ranking and then US new rankings. Apart from that, we also contributed to many pro bono initiatives. Not long ago, we released the Belt and Road report together with the Chinese Academy of Science. In response to the emerging hotspot challenges, we continue to renew our reports. And today, we want to focus on the low carbon research and to provide a platform for our future discussion on the carbon neutrality and low carbon technologies. First, let's look at global distribution of low carbon research. From this map, we can know the recent development of low carbon research. Over the past 10 years, the research has been booming across the globe. And in terms of volume, China tops the world with over 120,000 essays publications. And India, this is followed by US and then India. That means that these countries attach great importance to low carbon research. And in terms of quality, Chinese publications has a very high FWCI with an index of 1. That means it's the global average. But China's FWCI is higher than the global average, and that of the EU average, but it's slightly lower than the US FWCI. If you're not familiar with the index, you may refer to the introduction in Scopus database. Apart from China, we could also set our eyes on Brazil and Egypt, the largest contributor in low carbon research in South America and Africa, respectively. In terms of international cooperation, you may find on the left side of the slide that 23.3% of the research had at least one pair of international co-authors. And our experts in this morning session mentioned international cooperation as a very important approach in boosting low-carbon research and development. And this is really important in terms of funding. In case you can't read it clearly, let me explain a little bit. Like the major funds are like Horizon, US-based, and Physics Science, NSF and NSFSC, all provided over 100 million US dollars in funds, respectively. Last but not least, low carbon research is interdisciplinary, and many experts have already combined the research in biology, medicine, etc., to talk about low carbon research. In terms of application, we could see that the research results has been a pace setter in its interpretation from research into action. In this slide, we could see that the translation rate of FWCI with a high rate of 52% of citation by patents. That means that the patent citing is very high when it comes to low carbon research. And in the middle, you can see the figures from the patent citing by patent offices in different countries. And on the right side, it shows the industry academic collaboration. 3.5% of the publications is a collaboration between researchers and corporations. That is a higher rate than the average research. That means low carbon research is closely integrated with the local production and local enterprises, and its application has been really fast. If we look at different countries and we compare different regions, you can see from the slide that these are the major cities or regions. In the past decade, the changes in the number and quality of research, including Beijing, London, Madrid, Sao Paulo, Madrid, New York, Quebec, Shanghai, including Hunan, and the purple dot symbolizes the Hunan province. Notably, Beijing, among those 10 cities, Beijing has topped all the 10 cities in terms of the number of research. In terms of quality, the annual FWCI has witnessed many fluctuations. In 2020, the city with the highest FWCI is Hong Kong, followed by Hunan province. That means that researchers in Hunan have conducted very high-quality researches. 379 institutions in Hunan province published 5,000 publications, collaborating with 1,600 research partners and accruing 221,000 citations from 2011. So that's very encouraging. So that's the distribution of the research. What about the hot topics in low carbon research? In previous presentations, we have already heard the hot topics many, many times. Let me take a closer look from the data perspective. Among the 4 largest fields in low carbon research alone, there is a wide breadth of interdisciplinary representation. And there are several highlight research clusters, including secondary batteries, as we have heard from the Korean experts about the reuse and recycle of second-hand batteries. So this topic is closely related to low carbon development. And the other is the another topic, hot topic is the electric power transmission networks, wind power, and renewable energies. The third hot topic is electricity in combination with economics, including many modeling of the global trend of measures, as well as research. Many experts have contributed tremendously. For example, Professor Guan this afternoon talked about the carbon emission accounting. And last but not least, the microbial fuel cells, anaerobic digestion, including the biomass biofuels. Obviously, you have kept up with the pace of the times. In that, you are already capturing the hottest topics in low carbon research. From these sectors, you are more likely to be develop highlighted researches and be noted by corporations. If we take a closer look at the microbial fuel cells, anaerobic digestion, and bioreactors, according to Scopus database, the total funding exceeded $8 million. All these are hot topics that are well funded. Hot topics in disperse may seem tremendous. And every 2 years, Elsevier analyzes citation patterns and publication clustering to assign publications into research topics. In recent years, we are happy to note that one hot topic is close to the material industry, including nanosheet, phosphorus, and potassium-ion batteries. It's with FWCI of 4.6. If you can still recall, the average level is between 1 to 2 as a high level, but this with a FWCI of 4.6, that means it's a really hot topic, a hot research area. Just now, many researchers talked about the 17 goals of the UN SDGs, as well as the contributions of research to the SDGs. But notably, the contributions to the affordable and clean energy. Apart from that, the other 16 SDGs have also been a motivation for many other researchers. In closing, I'd like to share with you Elsevier's actions towards carbon neutrality. As the largest global publisher, Elsevier has been committed to leading the publishing industry. And in terms of carbon neutrality, we have made our own commitment to carbon neutrality and the reduction of carbon emission. On the other hand, within our group, we focus on the sustainable development culture, and we consciously fostered a sustainability mindset so that everybody will be aware of the sustainable development. Also, we worked actively with many partners, including many elite experts on the edge-cutting reports, for example, Lancet, together with its expert authors across the globe, have worked together to launch a Lancet countdown on the emission target. Also, we offered advisory services for researchers to contribute to the carbon reduction. Taking this opportunity, I wish also to welcome you to tune in to Times Higher Education's Climate Impact Forum, where we will release our pathways to net zero, the impact of clean energy research. This is Elsewhere's upcoming latest report on SDG 7. In this action report, we consulted many energy experts across the globe, and I'm honored to say that Professor Guan was one of our advisors. I hope that more people, more of you will pay attention to our release, so that we also hope to better support your research. I want to cite the former UN Secretary General Ban Ki-moon. He said that this report presents data that will enable informed decisions when joint roadmaps and joint action among all stakeholders around the world. I hope that you'll find this report truly helpful, and together we will strive for carbon neutrality. Thank you. If you're interested in this report or the data sets, you're welcome to contact me.
Thank you for this interesting sharing and from a fresh perspective to look at the new development of low carbon development. Now let's move on to the panel discussion. And we'll have both online and offline panelists. For the offline, we have Vice President Liu Ya of Research Institute, Fine Work, New Energy Technology from Hunan. And the moderator will be Professor Guan Dabo from Tsinghua University. Thank you. Thank you, all the panelists, for joining us. We have 5 experts joining us for this panel discussion. I have several questions for these 5 experts. I hope if you have other questions, you can also raise those questions online and offline. First, let me introduce the panelists. Mr. Liu Ya, Vice President of Research Institute, Fine Work, New Energy Technology. And Professor Gao Ling, researcher of Institute of Engineering Thermophysics, Ccus. And Professor Yu Ka Kim, chief researcher and from Korea Battery Industry Association, Professor Wang Tao, Zhejiang University, and also Professor Xiong Yaling from China Hydrogen Alliance. First question is for President Liu Ya. So in terms of low carbon technology deployment, what's your perspective on innovation and feasibility? What are the key factors in your mind? So the question is for you, Professor Mr. Liu Ya. I think this question has been raised for a long time, and there are a lot of debate on this issue. I think there are two aspects. First, it's on the energy perspective. We have a high carbon, low carbon, and zero carbon energy. And the second is application. We have high carbon, carbon reducing, and also negative carbon technology. Both each has different cost, and there are a lot of debate around these issues, and it has become a ever more urgent matter. But all in all, the cost is still the major issue, and that's the obstacle for many enterprises to apply these technologies. So that's about the feasibility. As for innovation, let me offer some personal thought. First is energy mix. In China, low carbon and zero carbon percentage is quite lower than European level, American level, and Japanese level. So there's a lot of potential to tap. Second, energy storage. Now, we have this inflection point. We require a major breakthrough. Now we have this 2021 wind energy exhibition in Beijing. I myself have visited this exhibition and find some new developments. Third is denaturfication and desertification, and the application of these technologies are developing. But the CCUAs are still has a very high cost, prohibitive cost. So if the government can have more incentives, maybe we'll have accelerated development in those areas. Lastly, I myself is from the manufacturing sector. In China, the manufacturing sector accounts for more and more, both in China and globally. So the low carbon technology application should not just aim at China, but also globally. Because we're talking about multinational supply chain, so we need to expand this application. Let me give one example, maybe 1 minute. Take this wind expo in Beijing. This is a Haskell software. The efficiency is better than GH by 5 times based on the same modeling. Why I talk about this company? Because when I talked with my clients, they ask us to lower costs. So we reduced a product, the number of processes of one product from 15 to 6. And we can see the real-time data from the inventory, production, sales, and from your cell phone, and can provide decision-making. Now, while reducing cost, we find it also contributes to low-carbon development. So I believe the guidance of government is really important. Thank you. Thank you, Mr. Liu Ya. Mr. King, can you also review, answer the same question, the innovation and feasibility of low carbon technology at the moment? King, can you answer the same question? What's the
Yes. Actually, I heard one word, which is the circular economy for low carbon technology. So we are trying to deploy to the user longer and user recycling. So I'm interested in the reuse and republication and recycling technology. That means the reuse and republication means to use more longer. Recycling means is the circular economy. We should go to the net zero until 2015. So for the target, the most effective industry is power generation and transportation, which means the renewable energy and electrical vehicle, also the energy storage system. In power generation, will be the increase of renewable energy generation, which needs the huge battery energy storage system. For example, in Korea, we have a target to 2015 net zero. We have planned around 85 gigawatt renewable energy generation, but we need some more power energy storage system around more than 300 gigawatt hours. How we can use the storage system? So EV car battery can be possible to use the energy storage system. That means republication, use the battery EV cars. Also the electrical vehicle and pure cell car will be the also the in net zero application. So for OEMs, will produce the electrical vehicle and for clean and low carbon technology for the EVSS with the renewable energy. So in my perspective, the battery is the most key technology to in net zero era. So I hope to the battery will be user application and then go to the for longer application like the energy storage system and some solar lighting and other portable storage system. And then go to the recycling. We go to the raw materials, previous materials, such as the lithium, cobalt, nickel, manganese. When go to the lithium-ion battery again. So I think the circular economy is most important to in low carbon era. Thank you.
好，谢谢 Kim 研究员这个回答。
Thank you, Dr. Kim.
我紧接着同样一个问题。
Let me follow up with my
想问林老师，什么样的这些工作
personal insights. I want to ask Madam Xiong Yaling what kind of actions can help accelerate the adoption of such technologies.
我是总呢是从两个
Okay.
维度呢来
I
看待这
would
个问题。
I would look at the issue from two aspects. One, the supply and low carbon technologies. The premise is that the technology must be ready. And the second, the cost of such technologies. That is, the economy is ready too. For the economy to be ready, there are two factors. One, breakthrough technologies. For example, the PV electricity conversion ratio must be high enough to reduce the costs. And the second is the scale of the mass production. So our solution is to conduct a region-based pilot plant instead of promoting the projects all across the country before it is well proven. For example, in China, a couple of years ago, local authorities across China released the clean technology application. In fact, those were really low, with a low efficiency, and that was really expensive. Second, we need to speed up innovation. But how to accelerate such innovations? Well, R&D must go first, because R&D takes time to trial for errors. And R&D is a process of trials and errors. And for every industrial revolution, there is a financial revolution. For example, the first industrial revolution gave birth to the bond market in the UK, and this time we are facing another revolution, and this time we will have a carbon trading market to help facilitate the transformation of the industrial revolution. Like Mr. Zhou Xiaochuan said, that for the carbon trading market to work, investment is the key. We need to channel the funds to help make the shift reality. But of course, we can also count on the government for subsidies and for specialized funds. In general, we think that the carbon market has bright prospects, and it will play a pivotal role in supporting the transition of the industry towards a low-carbon manner. And this year, we are witnessing a start of such a emission trading market. Second is the consumption end. If every individual has such a preference for green consumption, that is, people are more willing to pay for a higher price, at a higher price for a greener option. This will also help accelerate the transition of traditional industries towards the low carbon way. For example, we are witnessing a zero addictive and zero fat food sells faster than traditional food. However, people may not necessarily buy a greener solution at a higher price. But I believe it takes time. Over time, people may change their consumption concept. So that's my thought. We need to solve the problem from both the supply end and the consumption end. Thank you, Ms. Xiong. And then I would also like to ask Mr. Gao Ling, out of how to accelerate the adoption of low-carbon technologies, and also another question, how to accelerate the deployment of the mature technologies, and how do they facilitate the reality of net zero emission by 2050? Thank you, Professor Go. I personally know CCUS better, so I would like to elaborate the issue from CCUS. First and foremost, we must have a clear understanding of the technology and sort out the relationship between policy, technology, and the market, the trilateral relations. And one concept or climate change response technology mentioned by IPCC many years ago is not so popular as PV technology or low-carbon technology. Why? Because we used to CCSP technology. We used to focus on that technology prematurely because the timing was not correct. When the technology or when the market was not ready, without the right policy, those projects couldn't yield good results, including the Technova. an earlier adopter of that technology also suspended the adoption. If we compare the roadmap with that of China, we'll see that China never stopped the promotion of clean technologies over the past decade. We have been promoting the technology, but on a smaller scale. If we don't have enough understanding or the correct understanding of the technology, and we force the government to offer subsidies or help the government to offer finance for it. If the timing is incorrect, the results wouldn't be good. Only when the three are ready. For example, when the government is ready, the government is promoting clean technologies on a large scale with large-scale pilot projects. We believe it is the correct timing. So again, we need to gain a clear understanding and sort out the right relationship between the market, the policy, and the technology. That's my understanding. Thank you. Thank you, Mr. Gao. And Mr. Wang, you have also been engaged in CCUS research. What about your view? Sorry, we cannot hear the speaker. We cannot hear the speaker. Just now, Professor Gao made the case correct. I want to make 2 points, another points. First, we believe we need to provide more support for technology. Relevant departments of the country must encourage the R&D, be it lab research or small-scale research. One typical technology is the carbon capture technology. Back in 2010, around 2010, when U.S. Ministry of the American Energy started to pay attention to the technology. In the past 5 years, the Ministry of Energy has gradually scaled up the support for that single technology, and now the financing is above $50 million for that one individual technology. So the financing is enough to ensure the smooth process of the technology. On the end users, as for the end users of the clean technologies, many are state-owned enterprises or big state-owned enterprises directly under the central government. For the costs to be lowered, as for the technology, we must encourage more private actors to engage in the carbon emission trading. So those are my 2 points. Thank you, Mr. Wang Tao. And thank you for elaboration on the CCSV technology as a case study. CCSV has also been critical in helping China to achieve net zero emission. And I now want to shift the focus on the general public. How can we raise the awareness of the general public to engage in the carbon emission reduction?
Thank you for the question. For low carbon transition, I think it is related to everyone. So I suggest every citizen need to participate in this transition. And we need to educate the low carbon transition concepts, knowledge through various methods and channels. Second, we need to conduct trainings, campaigns, and also some experience activities so that the general public can understand low carbon transition easily. And third, while promoting all this work, we need to cultivate low carbon lifestyle, especially among youngsters, to cultivate their low carbon lifestyle. Of course, it cannot happen overnight, but we need to start now. And it's not just applicable to China. Actually, I think China have already started work in these aspects and has some good practice experience. We also can promote these practices to countries along the Belt and the Road to let them understand our good practices. Thank you. That's my perspective.
谢谢周老师。
Thank you, Professor Zhou.
我再问一下Kim，
Kim, Professor Kim,
您在这边能分享一下
can you also share your perspectives or maybe practices in Korea or maybe other countries you're aware of, how to educate the public to participate in low carbon transition?
You're muted.
Sorry, please turn down your microphone.
Yes, sure. Yes.
Can you share some experience of yours about the how to increase the public awareness in the low carbon transition?
Yes, actually, I saw one infographic that is kind of the low carbon transition society. So the most impact of the action of the low carbon transition is to replace the gasoline car to hybrid car. The next step, action to change the hybrid car to EV car. So finally, the people have to use the cycling and just walking. The most important things to, but I believe that the situation, like the low carbon production by technology innovation and clean energy generation and long cycle life by the publication. So I think the people, they need some participants to the how they help to the low carbon economy and low carbon society to reduction of some wasting and reduction save the energy efficiency to replace the high efficiency electronics and EV cars and other things. So I believe that we have to make some situation how they can use the low carbon production by technology innovation and clean energy generation and long cycle life by the republication and anything. I visited several recycling companies that has a worse situation too, but so government, they don't have to just the limited limited special region to recycling industry without any supporting for the R&D and promotion. So I think the information of the most important thing to the people, such as the carbon footprint for production, how this product made by from the how many carbon generation, how they reduction the some other environmental issues in the wastes. So then industry will try to develop the no carbon production, then people just use just simply. So I think in case of Korea and other countries, they are trying to the low carbon production or low carbon condition like the sustainability things. So several companies, they are already doing or reporting for the sustainability report for every year about how they reduction the carbon dioxide, how they to help to the environmental issues in the world, earth, and low carbon things. So then when people, they are just checking to the how they buy to the production from the companies, how they make that carbon footprint. But right now, this is so far things. I hope to the information to about the low carbon production is most important to open to the information to the customers. Yeah, thank you.
Thank you, Dr.
Thank you. Last question. First is for Professor Gao. Can you share with us what's your perspective on how to strike a balance between economic development and carbon neutral? Thank you. Personally, first we need to have a correct understanding of the relationship between economic development and carbon reduction. We have to face the cost. In one of my lectures, I joked. I asked them, do you believe in climate change? 2/3 raised their hands. However, I'll ask another question. Please donate 500 yuan if you believe in climate change, and then all put down their hands. So that's the case in reality. Yes, carbon neutrality is an opportunity to upgrade the economy. However, unless we can understand the cost we have to pay to achieve carbon neutral, otherwise we don't know how to cut the cost, how to promote economic development. Now, many people are studying carbon neutral, but mostly on strategic level, but very few, a lot fewer on the economic impact. If we have misunderstanding what the cost will be and what's the gap between a wrong estimate and correct estimate. So to talk about the ambition is easy, but to talk about money is another different story. So what's the relationship between economic development and the carbon neutral? What impact will be if we made a wrong choice? Secondly, we need to price carbon. In the last 2 decades, I believe the reason for the slagging development is because we don't have a correct carbon pricing. But China is now building a national carbon system, and this carbon pricing mechanism, once set up, it can help the technology be better marketable. That way, we can have a better play of the market role. Thank you. Thank you, Professor Gao. The same question for Mr. Liu Ya. So what's your understanding, maybe from your company's perspective or your personal perspective, on the balance between economic development and carbon neutral? First of all, economic development and low carbon development, I don't think they should be attached equal attention. Currently, we have a delicate situation globally. As a patriot, I believe we need to focus more on economic development. But we also need to pay attention to green development. On the other hand, as a president of a research institute. Technically speaking, I believe we need to improve energy efficiency. No matter for solar, wind, or other renewable resources, we need to improve energy efficiency. In high school, we talk about oxygen enhanced combustion. This is a very easy way to enhance energy efficiency. We can also increase the wind power efficiency and biomass efficiency. All these are workable. I also have a suggestion. That is carbon certification. No matter for our company and I myself, I think we have worked a lot. So I suggest to have a carbon certification for companies, schools, individuals. So with such mechanism, I think more people will be more encouraged to participate in low carbon development. So moderator and Professor Xiong mentioned this is an age of revolution. Without a low carbon concept, I believe will be phased out. In recent months, I stayed in Shanghai. You know, the waste classification has been promoted well in Shanghai. If you cannot adapt to these new measures, I believe you will be lagging behind. And we also need incentives. All the efforts should be rewarded.
So reward is an important thing too. Thank you. That's my perspective. Thank you, Mr. Liu Ya. And thank you, our distinguished guests and our audiences for coming for this panel discussion. I will now shift the floor to the floor. Shift the floor to Professor Liu Xuedu for a conclusion. Thank you, Dr. Guan Dabo, and thank you to all our panel guests. And now the floor is given to the lead climate change specialist of ADB, Mr. Liu Xuedu, for a conclusion. Thank you. A special thank you to our audience present at this conference hall. It's been a long afternoon. And we are actually 20 minutes longer than expected. If I would like to offer you a comprehensive conclusion, I think it's beyond me, and I think you would be unwilling to listen to me. So I will just give a very simple closing remarks and stand to be corrected. If I may, I will finish in just 3 minutes. So our keynote speeches and panel discussion this afternoon are all about high-end technologies, and they can be classified into the supply end, supply of clean energy, and the application and about the application of batteries, hydrogen power, as well as the biomass fuels. I think those are all the edge cutting in the clean technology field. But we must not neglect. Let's not overlook the more technologies that could be cost effective. For example, the industrial improvement because the processes of industrial production can also be improved, can also add to higher efficiency. And more importantly, we need also pay attention to low carbon in our daily life, for example, the design and the packaging of consumables. So when speaking of low carbon technology, we need to consider both the high-end technologies and the daily items. Only in this way can we integrate low carbon into the daily life of the community. So that's based on my personal observation. Second, how to apply the technology, how to put such technologies into practice. Our experts have also some very sophisticated technologies which require both policies and the market to support. But I want to say that technology is important, policies are important, and market is important. But don't forget funding. And let's not forget the public engagement. It must be a choice of the general public before a technology can be converted into our daily life. That is, the acceptance of the general public matters. We must foster a community where everyone will contribute to the R&D, investment, and development of clean technology. We need to create such an ecosystem that is pro to low carbon technology. And I wish to add some of my personal remarks. I want to thank our keynote speakers. I listened very carefully to each and every one of them. They had made very good cases in their special areas of specialty. And I hope that we can hear more from them, because I have learned so much from their presentations. And also, I want to thank our audience, offline audience. Your participants matters equally. Apart from that, I see many other audiences online who are listening, joining us online. A special thank you to you as well. Our gratitude also goes to all our other teams, including interpreters and the live streaming team. That concludes my remarks. Thank you, and enjoy your supper. Thank you again. That concludes our parallel session 1.